Hey guys, it's April 8th and we are starting a new chapter in chemistry. That's chapter 14, which is chemical equilibriums. And I started trying to do a little demonstration for you guys. Of course, it doesn't look that good here. But this is supposed to be a reversible reaction. I have kind of had to, go through the pantry and figure out different things because I didn't quite have everything. But this is water, and what we did with the water, and I didn't quite have the same size flask I needed either, and I didn't have a stopper that didn't have a hole in it, so we'll just see if this works. But this is basically water that I have dissolved some sodium hydroxide in, and then we were supposed to put glucose in that. And I didn't have glucose. I tried sucrose, which sucrose would be like table sugar. And then we were supposed to put some, what was it called? Methylene blue solution. I didn't have methylene blue, so I tried putting in some methylene orange solution. And I kind of think it's not working. Because what's supposed to happen is after I mixed all this together, eventually, and maybe it just takes more time, but it should have happened during our class time, and I've been looking at it for a couple of hours now. It's supposed to go back clear. Now, this looks like a urine sample from where you're at, so it's really, but it's supposed to be more orangey. And so to me, I can watch the orange. It seems to come more of a pale orange, but it's not becoming clear like it would with what it tells me it should do with the blue glucose version of it. So, oh well. That's another experiment that's not working. Hopefully, maybe tomorrow I can get a different demonstration for you guys. So turning to chapter 14 in your chemistry book. Chapter 14 is not going to have a test on it. It's just going to have a quiz. And just so you kind of know, I've sent a text out on April 6th, but just so you kind of know what's happened, you have a test, you have some quizzes. I'm sending home a quiz on chapter 14 along with your test. That's what's being mailed out to you on April 6th. And all of that's due April 15th because the initial quarantine is supposed to end on April 14th unless it's extended. We just don't know what's going to happen. So hopefully you're able to get that to us, if not anything else. So in chapter 14, what I'm mainly doing is we're going to go over your terms, maybe some quiz questions that you might have, and then we are going to start chapter 15 next week, which will end up being the 13th, I think. Yeah. So on chapter 13, chapter 15 will begin on the 13th of April, and we'll just go with that and see what happens. And that's more interesting chapters like acids and bases, and there's a few more calculations. So chapter 14 is mainly going to be a term chapter. So if you'll turn to it, you can see what your symbols and big abbreviation is. So the K is standing for like the equilibrium constant. And then when you have the KSP, that's your solubility product constant. So let's just talk in general what kind of happens with if you took some sugar and you heated it in a test tube until it charred. We've actually done that experiment a few times. I've done it with my younger kids too, and it actually smells good. It reminds me of like a marshmallow burning or something. We just put it in a test tube, and as we passed it over the test tube, you remember it turned into this brownish looking water. So technically what happened is the products of carbon and water is what took place when we added heat to table sugar. If you tried to take the carbon and the water and then make it back into sugar, that would be impossible. So such a reaction of us burning sugar is an irreversible reaction. It occurs in only one direction. Plants can produce sugar from carbon dioxide and water molecules by photosynthesis, but even plants cannot combine carbon and water or carbon dioxide and water directly to form sugar. So the reactions we have studied in earlier chapters have been pretty much treated as reversible reactions. In some reactions, however, the products do react to a certain extent to again form reactants, and these reactions are called reversible reactions. So that's a bold word on page 235. So go ahead and start highlighting. I hear a saw. So let's go ahead and start highlighting reversible reactions. And this is a term quiz question. Reversible reactions are reactions that can be made to go in either direction. That is, from reactants to products or from products to reactants. And reversible reactions will be studied during this chapter pretty much. So if we start going on down, the element hydrogen was discovered by Sir Henry Cavendish. In 1766, he passed steam through a red-hot iron red-hot gun barrel, and the reaction occurred as shown to you on 14.1. Since one of the products is a gaseous hydrogen, it escaped as it forms. If the reaction occurs in a vessel open to the atmosphere, then the reaction goes only in the direction shown. If hydrogen gas is then passed over hot magnetic iron oxide, then the reverse of the reaction occurs. And similarly, so this is a reversible reaction is what they're talking about. It's using iron filings and what happens with steam going back and forth. We really don't have that, or if we did, I would probably have to get more equipment than what I've got. So let's go on over to chemical equilibrium. So in chemical equilibrium, both of the situations that were discussed, that's up above, talking about this iron oxide and hydrogen equation going back and forth, both of the above situations occur in an open system. But if the system's close to the atmosphere so that neither the gaseous products can escape, both reactions occur simultaneously and all four substances are present in the vessel. So if you could close the vessel containing iron oxide and hydrogen and heat it, initially the rate of reaction between the water and the iron will be high because the hydrogen's high. But as the reaction proceeds, the concentration of the hydrogen will decrease and it's consumed. And the reaction rate decreases simultaneously. The reaction rate between iron and water is increasing because the concentration of water is also increasing. It's being produced. But eventually, the rates of reaction in opposite directions will become equal, and there's no further change in the amounts or concentrations of the substances involved. So what's supposed to happen in my demonstration that I'm doing today, which is not working, but it was supposed to, after a while, this time sets, it will set, and eventually all the oxygen will be taken away since it's stoppered, and this solution would be clear. And I could make it turn blue again by taking the stopper out, letting a little oxygen go back in, and then shaking it, and it should turn blue. So it should go back and forth. Like I said, this is not working. So I really need to order exactly what we need for stuff. But you do need to know what we just went over. Eventually, the rates of reaction in opposite directions become equal, and there's no further changes in the amount or the concentrations of the substances involved. The system becomes into a state of chemical equilibrium. That is on your quiz. So on page 236, your first bold word is chemical equilibrium. That's a quiz question. What do you have to know about it? It's when rates of reaction in opposite directions become equal and there's no further changes in the amounts, or the concentrations of the substances involved. That's what you have to know about chemical equilibrium. So I'm going through, like I said, we're trying to shorten this up for you guys a little bit so you're not here forever. If you go under equilibrium concentrations, it's giving you several different chemical equations going over dynamic equilibrium versus, equations that go to the right, go to the left, those type things. You may read that over yourself to get through that. But for this first section, that's pretty much what you have to know in that first little section. Now, let's go on to, hold on, let me get this guy's name. His name looks like Le Chatelier's. So Le Chatelier's principle, since he is French, that's how we're going to say it. So you have to know what his principle is. I'm on page 237. And it's explained there for you just a little bit down. So you do have a question, though, that doesn't seem to be explained. You remember, sometimes I try to explain this to the side. So I wrote this question out beside Le Chatelier's principle, just so I can remember to tell you guys this. It is where relative concentrations depend on the reaction. So Le Chatelier's principle, overbroad, basically is relative concentrations depend on the reaction. So reactions that have reached an equilibrium state reach equilibrium have done so because the forward reaction toward the right is occurring at a rate that exactly opposes the rate of the reverse. So both forward and reverse reactions are continually occurring. Because of this fact, any factor that changes the rate of either the forward or the reverse reaction will upset the equilibrium so that they're no longer equal. Any such factor is known as stress. If the forward reaction occurs faster, then the reverse reaction under such a stress equilibrium is said to shift to the right. But if the reverse reaction occurs faster, the equilibrium is said to shift to the left. Eventually, the forward and reverse rates will again be equal, but there will be different concentrations of products and reactants present in this new equilibrium state. The rule used to determine the direction in which a given stress will cause an equilibrium, this is another quiz question, is Le Chatelier's principle, which was formulated, oddly enough, by a guy named Bob Brown. No, it's by a guy named Henri Le Chatelier. So what you have to know about Le Chatelier's principle, one is what I gave you, that when relative concentrations depend on the reaction, that's Le Chatelier's principle, but also down here at the bottom, if a stress is applied to a system at the equilibrium, the system will react in such a way that the stress is at least partially offset. Another quiz question that comes from Le Chatelier's is that it minimizes the effect of stress too. One principle of Le Chatelier's principle is that it minimizes the effect of stress. So we've done Le Chatelier, then it starts going through all the concentration type changes. So, and this is where I started off. In general, increasing the concentration of reacting molecules will also increase the rate of reaction. For similar reasons, a decrease in concentration will decrease the rate of reaction. So increasing the concentration will increase the rate of reaction, and decrease the concentration of a given substance will decrease the rate of reaction. Or relative concentrations depend on the reaction. So to illustrate this, they go over a sulfate and oxygen combination that they're showing on page 237. And they also show you some diagrams on page 238. And you can read through here. What I want you to just read on your own until you get to the chemical equation that's up here that's called 14.7. And then read the words underneath there and highlight them as a quiz question. If a product is continually removed as it forms, the reaction toward the left has little chance of occurring, and the forward reaction is then driven to completion. So there's like a test question, it might be a multiple choice question that kind of has that idea in there. So if a product is continually removed as it forms, the reaction toward the left has little chance of occurring, and the forward reaction is driven to completion. So we can relate dynamic chemical equilibrium to the static equilibrium of a balanced seesaw, and they give you a whole explanation there why. When a substance's concentration is decreased in an equilibrium system, the equilibrium shifts in the direction that produces that substance. When a substance concentration is increased in an equilibrium system, then the equilibrium shifts in the direction that consumes some of that substance. So let me see how much further, because this is a really, really short chapter. I don't want to do, So I think what I'm going to do is I'm going to end that there. We're going to start up. You got about half of your questions, I think. We'll do the rest of them tomorrow, which will be April the 9th. I'm looking at my calendar. And then I will not produce a video on April 10th because I'm going to wait. I'll just give you a chance there to finish up tests, finish up quizzes, finish up the quiz on chapter 14. And so there'll be one more video this week, And then next week, we will start a chapter 15, which is going to be a total new testing chapter, along with the next chapters. 15 and 16, I'm pretty sure, test together. I'll just have to check on that one. So have a great day. I know that was a short lesson. You all are so sad about that, aren't you? But have a great day, and just remember to rejoice in the Lord always and to stay well. So see you guys.